All right, hey everybody. This will be a short one. I just wanted to tell you guys how to run DiaNN on the cluster without splitting things up. And if you want to just run DiaNN normally on Linux without splitting it in the steps and just running it like you normally do on your GUI with Windows, but without the GUI, this will show you how to do it. And this is how I do it on my cluster here at UC Davis. So anyway, I'm wearing another hat today. This is from my grandfather's collection. I asked ChatGPT what it was. It says it's a men's fedora, specifically a mid-century felt fedora from the 50s or 60s by Ramelty, designed for Hughes and Hatcher, which was a high-end men's clothing store in Detroit. So we're originally from Detroit, so that's where these all came from. So probably it says it's probably from the 50s to 60s, probably. I don't know. What does it say? 1950s, 1960s. So anyway, that's what this is. I have a few more. I'm going to have to figure out some other videos to make so I can show them to all you guys. So anyway, so what I am doing to run DiaNN on my cluster, and I actually think it can actually be a lot easier than running it on Windows. The first thing you have to do is you have to put it in a container. So at least on my cluster, and I think this is probably on most clusters, you'll probably have to run DiaNN in a container. And on my cluster, I use Aptainer, which is the new version of Singularity. And so on my previous video, I showed you guys how to do this. So you can open the link in my video running DiaNN on a high-performance computing cluster, and it gives you some steps here on how to build an Aptainer. So basically on your cluster, you'll do a module load Aptainer. Most clusters use, academic clusters use modules. I've only used an academic cluster, so what do I know? And then this little code comes from Vadam's GitHub site somewhere in the support documents. And this will actually build a definition so you can build your Aptainer. And the only thing you want to change is you want to change this link under wget, and that will come from here in DiaNN. So you go to their GitHub page, releases. We're going to use the 2.3.0 Academia Linux preview zip. Right click, copy link. And then you go to this little code here and place that out. And don't forget to change the unzip from 2.01 in the example to 2.30. And then what you do is you run this little command, Aptainer build. This is your definition file. No, this is your output file. So you want to give this a name like DiaNN 2.3 or something. And then use your definition file. And then you can execute it to verify that it works. Aptainer exec, your container, and then that's this little line here, which tells it where the actual executable is, and then V to verify the version, and it should run. So if you don't get that step, none of this will work, but it should work just fine on any cluster. And so how I and ChatGPT set up the script is you actually put the container in a directory, and within that directory you make 3, and you don't have to put the container here. We can define where the container is in the script. But basically I have 4 folders, one called data, and that's where I put all of my runs, or all of my analyses. And you can see I have, I think, 32 timsTOF runs from a salmon digest I was messing around with. And then FASTA, and you'll want to just dump your FASTAs here. So I have my salmon uniprot FASTA, and I have the universal protein contaminants, which I really like. It's from a 2022 paper. And anyway, if you want to know what that paper is, just ask me in the comments. I can put it there. I have a library, so if you have a spectral library that was predicted from DiaNN, you could throw that in there. That would be a speclib file. And then I have an out directory, so these are where all your outs go. And you can see I've already ran it, so all of the outs are here. I have 2 scripts here. One is where I have just the regular DiaNN script to run it through Slurm. That's an etchbatch file. I just call it etchbatch, really, like a text file. And one where I turn normalization off. So sometimes when you're doing affinity purification or some sort of IP, it can be pretty useful to turn the normalization off. So I have one with normalization off and one with normalization on. And let's look at it. Let's look at the script. Okay, so you can find this on my GitHub site. I'm not very good at GitHub, but anyway, it should be here. And this is kind of what a Slurm script looks like. So you give the job a name. They don't want me hogging the HPC, so they limit me to 64 CPUs per task, which is really lame, guys. But anyway, that's what the cluster people tell me. They let me use about 1 terabyte of RAM. I think the first time I ran this, it ran out of RAM. And it doesn't seem to be, if it runs out of RAM, it seems to crash, unlike the Windows version. So I set this for 512. I think you're safe if you put it at 128. But I did put it at 64 and it ran out. So I think 128 should be okay, but they let me use about 1 terabyte, so I put 512. This is the time the job can take, so it can take up to a day before the cluster kills it. These are where the out and error files could be named. This is just some of my cluster stuff. So this is my account on the cluster here at UC Davis partition I'm using. So for this script, all you do is you set your working directory. This is where all your subdirectories are. You don't actually have to have them there. You can modify this. So, it sets the working directory as a variable, and then you can set all of your subdirectories here. This also tells you where your container is, but you can modify this and put wherever you want. If you don't have an out directory, it'll make it, and then it'll do the module load Aptainer to make sure Aptainers are loaded. And then it does some code here to look through your data directory and select all of your files that might be in here. Right now it works with raw files, mzml, or .d, timstuff stuff. So this will add the file flag to your DiaNN command line interface. It'll do the same thing for the FASTA files. So this will be if it finds the FASTA files in there, it'll add those to the FASTA flags. It will also has some code to detect if you have a spectral library. So if you already have a spectral library in your lib subdirectory, it won't bother to predict the new one. So it'll just use that. So it's a little tiny bit smart, although it's still kind of stupid. But if you have your speclib file already pre-predicted, you may not want to have it predicted again, although DiaNN's pretty fast these days, so you might as well. All right. And so if a spectral library is found, here's the command line options that it runs. This is normal default DiaNN. You can add other variable modifications. It'll use the quant files if you already have them. If not, it ignores it. It tells you where the output file, and you can see this one's already wrong. I need to fix this. So this should just be report, because this is actually the non-normalized one, but this is actually the normalized one, but I'll fix this. So anyway, that's where the reports are going to go. And then here's the FASTA search. So if it finds there's a FASTA file, no speclib, it then runs these. These are pretty similar, and it saves everything in an out file. So I'll show you how that works in practice. And so where's my terminal? Here we go. All right, so I'm already in my directory. I can see I have my data directory. I can see what's in there. You can see I have all my salmon.d files in there. I also have my FASTA, my library, and my out. And in order to run it, I just go, here's the script. I'm going to run this one because I'm going to leave normalization on. So then I go sbatch. That's the normal Slurm thing to run it. And then I give it that file, boom, to .sbatch. And bam, it submits the job. So I've submitted successfully job 5,467,944. I could see if it's running. I do this command called sq, give it my username. There's other ways to do this. And you can see it's running. When it starts running, it will give you an error and out file, and you could see the file name is 994, and that would be these two right here. And so you could see it probably hasn't started populating yet, but we can open this in a text editor. Let's see, and where did it go? There it is. Okay, so you can see this is the log files, how it's started already, DiaNN 2.3.0. It can tell you if you've done anything wrong. You probably want to change the mass accuracies in the scan windows for your data set. And then it's 32 files will be processed. If on the FASTA file, it'll start predicting it, and then it'll start running it. And when you're done, here's what one of the, let's see which one actually worked. These all worked, but let's do this one. We'll open it. This is the one I did last night. Let's see. You can look at the whole log file and see if there's any problems. And it did everything correctly. The job is finished. It gives you some statistics at the end. So you can see this one only, I requested 512 gigabytes. It only used 71 for this one. And let's see the other one, because I think they were a little different. Open with. And good HPC or high performance cluster etiquette is that you should only request the amount of RAM that it used. So I would probably request 128. So I'll change my script to only request a little bit more than what it used. So I don't need to use 512. All right, and then once it's done, you look in your out files, you get all of your normal out reports. I had it make the XICs. It has the gene group matrix, the peptide matrix. It has the parquet files, the protein group matrix, which is around here somewhere, right there. Those you can load in DIA Analyst. I'll probably have a video about that later. And so I think that's it. I think we're done. And I can see if it's still running. Boom, still running, and I'm going to kill it. S-cancel user .sv, boom, and that should cancel the run. So anyway, that's how you do it. You can load up runs after runs after runs. I think this is a really simple way to run it. The script's kind of dumb, but it's a little smart. So anyway, that's it. And DiaNN will work and run in a cluster, and you could just load up your files. And so this is a pretty easy way to do it. All right, I think that's it. I'll put a link to the GitHub site with that Slurm script. You guys can run it on your own cluster, get DiaNN working. And I really like running it this way. It's really cool. So for those of you who have a cluster on campus, you can run DiaNN pretty easily, and you don't have to run it on your desktop computer. I've been really happy with it so far. All right, I think that's it. Okay. All right, bye everybody. I'll see you next time.